Okay, so here's a related rates problem solving question. It's that balloon that I've kept talking about, which I didn't expect. A balloon is being filled with air at the rate of 150 centimeters cubed per second. So there's a rate. Assuming that the balloon remains spherical, at what rate is the radius changing when the radius reaches 3 centimeters? So at what rate is the radius changing? So a rate is radius with respect to time. So let's just do a little bit of drawing here. So we want to know at what rate is the radius changing. So we want to know the change in the radius with respect to time. So given that this is sort of a related rates question, we probably need two things. We would like to have, I always have to do this, it's just the easiest way to do it. dRdt, dRdt. The other thing that I'm going to have is, so a volume. Change in volume, change in volume. So a balloon is being filled with air at the rate of 150 centimeters cubed per second. Now that's a change in volume with respect to time. So that's dV dt. If only I had dr dV. So the way to find dr dV, now radius and volume are directly linked. So what I really need to do is just link radius and volume using some formula. So I just need a formula with radius and volume in it, and that's pretty obvious for a sphere. So the volume of a sphere is equal to 4 pi r cubed on 3, or 4/3 pi r cubed, whatever you want it to be. All right, so now that I've done that, there's probably two different ways I can do it. One's going to be easier than the other. It doesn't matter which you do. Now, what I can do is rearrange it to make r the subject. If I make r the subject, I can do dr over dv directly. But given that v is the subject, I can just find the derivative of v. So that'll be d. That'll be dv with respect to r. So the derivative of 4 pi r cubed over 3 is just going to be 4 pi r squared. But I don't want dv dr, I want dr dv. So dr dv is going to be the reciprocal of that, 1 over 4 pi r squared. So now I have this guy here. So that's dr dv, that's dv dt. I wanted dr dt, which is going to be 150 over 4 pi r squared. So now that gives me the change in radius with respect to time, and it says at what rate is the radius changing when the radius reaches 3 centimeters. So really simple from here, let r equal 3. That means that it's going to be 150 over 4 pi 3 squared, which is 150 over 9 times 4, which is 36 pi. So that's the rate at which the radius is changing with respect to time. You can probably make that 50 over 12, 25 over 6, something like that. 25 over 6 pi. So we can finish off by saying when r equals 3, the radius is changing at 25 over 6 pi centimeters per second. The units will match up with the units that we've been given. All right, there's our related rates problem using a chain rule.